Welcome everyone. Guys, in this video, we will solve some questions relating to KPC or K partition. Most of the questions are related to this topic are easy, but the last question is kind of hard. It's not hard, but takes very long time. Yeah. So guys, if you watch this video for the first time, or if you watch my channel for the first time, I hope you subscribe and give like for this video. This is quite encouraging making more videos. So let's get started with the first question. So ammonia is soluble. Guys, I hope you stop the video, take a look, and then you go back. So ammonia is soluble in both water and organic solvents. Guys, organic solvents usually are non-polar. Aqueous solution of ammonia is shaking with immiscible organic solvents, trichloromethane. This is the organic solvent, trichloromethane. The mixture is left to reach equilibrium. Samples are taken from each layer and titrated with dilute HCl. And we took 25 of trichloroethane layer. This one also has NH3, don't forget. It needs this amount of HCl. So guys, you know, to reach endpoint, you know, HCl react with NH3 1-to-1 ratio moles. This will give us NH4Cl, okay? Yeah, and here the same way we did the same. We take 10 centimeter cubic of aqueous layer from the aqueous layer and requires this amount of HCl to reach endpoint. This amount will help us to find out what's the concentration of NH3. Calculate KPC, K partition of ammonia between trichloroethane and water. شوفوا guys, look. Ammonia between trichloroethane and water. So here guys, in calculating KPC, you know KPC equal to trichloroethane, the concentration of substance in first layer over the second layer. So the first layer, the layer that will be top here is this one because it is mentioned first, and the concentration of ammonia in water layer will be down, okay? It will be like this. So first of all, I'm going to find out the concentration of ammonia in here. So look, as we said, HCl react with one molecule of NH3 to give us NH4Cl. Don't forget this. Let's calculate here the moles of HCl needed for this reaction to react with 25 centimeter cubic. So guys, you know that concentration, which is 0.1, equal to mole of HCl over its volume. Guys, its volume will be 0.03. We divide by 1,000 to convert to decimeter cubic. This will make the mole of HCl equal to 0.0013. This is the moles of HCl requires to react with moles of NH3. Because in the equation, guys, that we wrote, we see that the ratio is 1-to-1. 1 mole of HCl react with 1 mole of NH3. 1 molecule of HCl react with 1 molecule of NH3. So this moles is equal to the moles of NH3 in solution. What we are supposed to do now, we are supposed to find concentration of NH3 in trichloromethane. So concentration of it will be equal to moles over volume. Guys, the volume is this, 0.025. We have to convert to decimeter cubic. So let's take a look, just 1 second. Let's have a look on the answer. This one will give us 0.013 over this will give us 0.052. This is, guys, the concentrate mole over decimeter cubic. This is the concentration of ammonia and trichloromethane layer. Now we do the same for the water. So we know that here we have the volume of HCl required to react with the NH3, and here we have the concentration. So we say that the same, 0.1 equal to X over 0.0125, because we divided by 1,000. This leads us that X, which is the moles of HCl, equal to 125, equal to this number. This is the moles of HCl. So you know this will be the same as the moles of NH3 because ratio, as we said, 1 to 1. So moles of NH3, guys, over its volume, the volume here we took is 0.01. Okay, because we took only, we took only 10 centimeter cubic. So this one will be 0.125. 0.125 mole over decimeter cubic. Now, guys, what we are supposed to do, we are supposed to find KPC. KPC, or K partition, will be the concentration of ammonia in this layer, trichloroethane, because it is mentioned firstly. So here we have 0.052 over the concentration of ammonia in water layer, which is 0.125. This one, guys, let me use the calculator. 0.052 over 0.125. This will give us 0.416. Guys, here we don't have any units for this, okay? KPC has no units. Let's move to the next question. This is another question. Guys, here in this video, we have only mathematical questions, calculations. So we don't care about the theoretical part because it's kind of easy. So water and octane 1-ol form 2 layers when mixed. Okay. Ethanamide, guys, by the way, octane 1-ol, we have C8. We have 8 carbons in this compound. This is non-polar because it has very long carbon chain. Ethanamide has this formula, CH3CO, NH2, is more soluble in water than in octane 1-ol because this compound is polar, water is polar, so like dissolve like. When 1 gram of ethanamide is added to 50 centimeter cubic of water, and this is then shaken with 50 of octane 1-ol. So first of all, we have now, we have 1 gram of ethanamide to 50 centimeter cubic. We have 50 centimeter cubic of water. So here we have 50 centimeter cubic of H2O. And here we are, to it we are adding 1 of ethanamide, 1 gram. After that, and this is shaken with 50, then we added another 50 centimeter cubic of octane 1-ol. It is found that the water layer contains this amount of ethanamide at equilibrium. Calculate the partition coefficient for ethanamide in water and calculate KPC for ethanamide in water and octane 1-ol. Water is mentioned here firstly. So we say that KPC, guys, we have to write the concentration of water up here because because we mentioned it firstly. So look, In KPC calculation, we can use the unit as gram over decimeter cubic or mole over decimeter cubic. Both of them are correct. Both of them give you the same answer. Look now, guys, what is the concentration of ethanamide in water? So it's found that the water layer has 0.935. This is the gram, this is the mass. We divide it by the volume of it, okay? The volume is 50, so it is 0.05. We convert it to decimeter cubic. This is, guys, the concentration of ethanamide in water layer. You can't do this one separately, but I prefer to do it now. This will be divided over or divided by the remaining, guys, the remaining. Don't forget we used 1 gram in the beginning, and in water the remaining is this. Okay, we used 1 gram, and in water we have this amount. So the remaining of the 1 gram, which is 0.065, the remaining, which is this, will be in octane 1-ol layer. And octane 1-ol layer has this volume, 0.05. So yeah, the question now is over. So here we have 14.4. If you divide them, you will find we have 14.4. As we said, we don't have any unit. Right, just let me erase this. Okay. And by the way, we wrote 14.4 because we have to give the answer to 3 significant figures, as you see here. Okay, they always use the 3 significant figures, so my answer should be given to 3 significant figures. This is, guys, the second part of the question. Another part of the question. The 50 of water containing this amount of ethanamide is then shaken with 100 of this under the same condition. 50 of water containing this amount of ethanamide shaken with 100 centimeter cubic of pure octane 1-ol under same condition. Calculate the mass of ethanamide. Calculate the mass of ethanamide that is dissolved. They need the mass and 100 centimeter cubic at equilibrium. Right. In the previous question, don't forget we find KPC equal to 14.4. Okay, guys. So look, KPC, which is 14.4, equal to concentration of ethanamide in what? Yeah, the water was above in the previous question, right? Just 1 second, let me check. Ethanamide in water, and yeah, the water was the above. So look, guys, now 50 centimeter cubic of water containing this. So this is the mass of the ethanamide in water. Guys, 935. Some of this mass will go to what? Will go to octane 1-ol layer. And the amount that will go to octane 1-ol layer, let me say it X. This is the original mass of ethanamide in water. After mixing, some of the mass will go to octane 1-ol layer. And let me say that this is the amount is X. Now, guys, we have the volume of water. the 50 centimeter cubic of water, so it is 0.05. This is, guys, the concentration of ethanamide in water. It will be like this. It will be given in this formula. Over the concentration of ethanamide in octane 1-ol. Guys, the ethanamide that goes to octane 1-ol is unknown, and it will be the X. Okay? Here, guys, we have the original mass in water minus the mass that goes to octane 1-ol. So this is the mass of ethanamide goes to octane 1-ol over what? I hope you guess over 0.1. This is the volume after dividing by 1000. Okay, so this is, guys, the correct formula. I hope that you are good at math. So for me to solve this equation, I will take this part multiplying it here. So it will be 14.4x over 0.1 equal to 0.935 minus x over 0.05. This 0.05 will be multiplied here. And then divide by 0.1. So you end up with 7.2x equal to 0.935 minus x. I did this one before, so I have the final answer. Okay, guys, but it is just simple math. This is, guys, the most important thing. You have to give the correct formula, how to write, how to express the concentrations correctly. This is the most important thing. And finally, guys, the mass will be 0.114 gram. We use 3 significant figures as given in the question. Okay, they always use 3 significant figures. So I hope, guys, you got the idea correctly. Right. We have here another question. This is a question, guys, I think it's from 2020, 2022, sorry, the newest paper. So let's see the question. The partition coefficient of procaine, I think, between octane 1-ol, once more we have this compound, and water is this, 1.77. Which one, guys, when we write KPC, which one will be above? The concentration in octane 1-ol over the concentration in water. I hope you understand the idea. We mentioned this one firstly, so it will be up here. Okay, so we have KPC. KPC is 1.77. Octane 1-ol and water are immiscible. A solution containing 0.5 of procaine in 75 centimeter cubic of water is shaking with 50 centimeter cubic of octane 1-ol. Calculate the mass of procaine that extracted into octane 1-ol. Guys, KPC is 1.77 equal to concentration in octane 1-ol. The concentration in octane 1-ol. So what will be the concentration of octane 1-ol? We don't know, right? Unknown. We want to find it, so it is X over the mass over the volume. So the volume 75 centimeter cubic of water is shaking with 50. So this is 0.05 over the concentration in water. Guys, look. First of all, the volume of water, let's write it. It is 0.075. This is the volume of water. A solution containing 0.5 of procaine. So we originally have 0.5. Originally, we have this in water. We shake the water with octane 1-ol. So some of the mass goes to octane 1-ol. We say that the mass in octane 1-ol is X. So the original mass that was in water minus X is the amount that goes to octane 1-ol. This is, guys, the correct way to express the concentrations. Okay, I hope you get the idea. If you don't, guys, just write comments for me. Here we have only just simple math. So let me show you how would I do something like this. I will take all of this multiplied by 1.77. So 1.77 times 0.5 minus X over 0.075 equal to X over 0.05. Okay, then we can also take this 0.05 multiplied here, right? We can multiply it here also. So, guys, as I told you, this is just simple math. Should we do it? It takes very long time. Yeah, so we don't have to do it. Finally, guys, you will end up with that X will be, which is the mass, equal to 0.271 gram. After do all of this math, you will end up with this. Oh, this is very simple, guys. The math, okay? It's IGC and CSE math. So this is, guys, the mass extracted, the mass of procaine extracted into octane 1-ol. We wrote the concentration of octane 1-ol above because it is mentioned firstly here. We suppose that the amount goes as X, so the original amount minus X. Right. We end with this question. Moving now to another question. And here, guys, the partition coefficient KPC of butanoic acid between ethoxyethane and water. You know, guys, what I'm thinking about now. Between ethoxyethane and water is a 3.5. Okay, is a 3.5. A solution containing a solution of 2 grams of butanoic acid in 100 centimeter cubic of ethoxyethane is added to water. We don't have the volume of water. This mixture left until no further change, concentration of butanoic acid in either solvents, they reach equilibrium. The mass of butanoic acid dissolved in ethoxyethane layer now 1.62. It was 2. Then it becomes 1.62. That means, guys, we have 0.38. But what is this 0.38? What do you think, guys? Think about it. Calculate the volume of water used. We need the volume of water used. So KPC equal to the concentration in ethoxyethane over the concentration in water. Ethoxyethane. So KPC, guys, is the 3.5. This one equal to the concentration in ethoxyethane. What it will be? The mass of butanoic acid dissolved in ethoxyethane was 1.62. But what is the volume of ethoxyethane? A solution 2 grams of butanoic acid in 100 centimeter cubic. So, guys, here we have 0.1. By the way, converting of units here is not that important. Okay, so you can use both of them, centimeter cubic or decimeter cubic. But for me, I prefer using decimeter cubic. This is more convenient for me. Right, this one equal to what? This one, guys, equal to the mass of, the mass of it in water, the mass of butanoic in water, which is 0.38, over the volume of water, which is already unknown, which is required. Okay, which is required. That's it. When you reach to this point, I can say 100% or 99% you take the mark. Okay, because it's just simple math. If you can't do this math, guys, don't do A level. Okay, you don't have to do it. So 3.5 times 0.38 over x will be equal to 1.62 over 0.1. X in this scenario, guys, will be 0.0821. But what is the unit? What do you think? The unit, guys, here will be decimeter cubic, because I used here decimeter cubic. They want it in centimeter cubic. If you don't convert, you lose 1 mark. So here we multiply by 1000 and we end up with 82.1 centimeter cubic. You get the full mark now. 3 sig fig, because we have here 3 sig fig. Hope, guys, this question now is clear for you. If it is not, just write me in the comments so I can write more explanation. Moving to the next question. Yeah, I think, this is the last one for today. By the way, I have a notes here in the previous question. Not note, but actually question for you guys. So as you see, butanoic is more soluble in ethoxyethane layer than in water. As we say, ethoxyethane is organic solvent, so it is nonpolar. But why butanoic is more soluble in ethoxyethane? We have more mass in ethoxyethane layer. So write me in the comments the correct answer if you know it. I already know, but yeah, you have to draw it by yourself, write it by yourself. Moving to the next question, guys. When 20 centimeter cubic of ethoxyethane were shaken with 75 of aqueous solution containing 5 of organic compound G. Okay, so in 75 centimeter cubic of water, it was found that 2.14 grams of G were extracted into ethoxyethane. Calculate partition KPC between ethoxyethane and water. We mentioned first ethoxyethane, so this one will be above here. 20 centimeter cubic of ethoxyethane, so the volume here is 0.02. We divide by 1000. What's the mass? 5 grams of organic compound G in 75 centimeter cubic of water. It was found 2.14 of G extracted into ethoxyethane. So here we have 2.14, right? We had 5. Yeah. Some of it, which is 2.14, goes to ethoxyethane. The remaining will be in water. So 5 minus 2.14. This one, guys, will be 2.86, right? Yes. So here we have 2.86 86 over 0.075, the volume of water that is given for us. KPC in this scenario will be, or K partition, guys, will be 2.81. 2.81. So the question is over. Actually, the first part of the question is over. As I told you guys, this question a little bit hard. So this is KPC between ethoxyethane and water. Keep this in your mind. We will need it. Let's move to the next part of the question. The next part of the question says, in a new experiment. Guys, stop the video here. Read the question carefully because you will need huge effort to understand what they are talking about. We have a new experiment now. I suppose you are watching the video after reading the question carefully. So 10 centimeter cubic of ethoxyethane were shaken with 75 of aqueous solution containing 5 grams of G, and the layers were separated. So we have 5 grams of G found in 75 centimeter cubic. And then we are adding 10 centimeter cubic of ethoxyethane. So some of the mass will go to ethoxyethane layer. Okay, will be taken to the ethoxyethane layer. Some of the mass. But what is this mass? We will calculate it, but not now. Let's continue reading the question. The aqueous layer was shaking with a second 10 centimeter cubic. The aqueous layer was shaking with a second 10 centimeter cubic of ethoxyethane, and layers were separated. The two organic layers were combined. Use KPC to calculate total mass extracted in this procedure. Quite confusing procedure. So here, guys, we need to know what is the amount of G extracted into the ethoxyethane. This is first of all of what we are going to do. So look, guys, KPC, which was what? 2.81 equal to, which one should be written above? I just forget, believe me. Let's get back to the question. Between ethoxyethane and water. So ethoxyethane will be written here. The concentration of ethoxyethane, of the substance actually, G in ethoxyethane, is mass over volume. Volume 0.01. Why? Because we use 10 centimeter cubic. Yeah. What do we have about the mass? The mass is unknown. I need the mass. It is not given. The mass of G extracted into the ethoxyethane, X. Guys, look. Let's talk about the water now. The volume of the water, let's write it. Yeah. But the question is, what will be the mass of G in water? It will be, guys, it was 5. But some of it goes to ethoxyethane. What it goes to ethoxyethane is X. We say this. So 5 minus X. This is, guys, the way of writing the correct formula, the correct expression. I don't know, guys, if this kind of math is difficult for you or not, but let me do this one for you. Okay, I will do the total, the whole math here behind this to find X. First of all, I will take this part multiplying it here. Guys, if you understand the math, just skip this part, okay? So it will be 2.81 times 5 minus X over 0.075 equal to x over 0.01. Okay, I just take this part, multiply it here. Then, okay, what should we do? Now I will multiply this here and here. So we end up with 14.05 minus 2.81 x over 0.075. And by the way, I will take this 0.01, multiply it here, okay? So this part will be only x, and here these things are multiplied by 0.01. 0.01. Okay, طيب. Let's remove this with this, cancel them. So if you cancel 0.01 with 0.075, you end up with 0.1333. This one will be multiplied by 14.05 minus 2.81 x equal to x. Okay. Now multiply this by this one and this one. You get 1.873 minus 0.374 x equal x. We will take this one to this part. So 1873 equal to 1.374 x. X in this scenario, guys, 1.36 gram. I hope, guys, you don't forget what we are talking about after doing all of this math. So what is this x, guys? This x is the amount of what? Amount of G that goes to ethoxyethane layer in the first experiment. In the first experiment, the amount that goes is 1.36. Look to the next part. The aqueous layer was shaking with a second 10 centimeter cubic of ethoxyethane. After doing this, we used a second 10 centimeter cubic. Guys, look. Now, in here, we had 5 grams of G in water. From them, we removed 1.36. So the remaining of J, the remaining of J is what? Is a 3.64. This is the remaining of J, right? Yes. Good. Yeah. This is the remaining of J in water. And we repeated the same thing here. But here we will use the remaining of J in water, because in a second experiment, we did a second experiment, and this is the trick. This is, guys, to be honest, one of the hardest, not hard, guys, take very long time and quite confusing. So what we are supposed to do now, we found the amount of G in ethoxyethane layer in the first experiment, and in the second experiment, we will do the same. So look, KPC, which is what? Which is 2.81 equal to the amount of J in ethoxyethane, the volume of ethoxyethane once more 0.01 over the concentration of J in water. Guys, the concentration of J in water is what? Who can tell? Think about it. It will be the volume here, 0.075. And look, we have the remaining of water is 3.64. And the new amount that will goes to ethoxyethane layer, which is X, this X. You will do the same thing exactly we did in this question, the same math, and you must end up with X equals 0.99. This is the amount of J that will be extracted into ethoxyethane in the second experiment. In the first experiment, we got this. In the second experiment, we got this. They need the total mass, so it is 1.36 plus 0.99 gram. Very long question, very tricky. I hope, guys, you understand it. And if you don't, as I told you guys, write me in the comments, guys. And suggest me, guys, if you have some problems with the questions, some kind of questions or topics, you can write them in the comments so we can make another video about this. Hope you guys understand everything. Take advantage of this video. If you do so, just give me a like and subscription. See you in the next video.